Welcome to Lesson 3 of Functional Programming with Bob the Developer. In the last lesson, you've learned how to filter an object within an array. In this lesson, you will learn how to manipulate every object with one line of code. For example, if you have an array of 3, 4, 5, you may use that function to convert 9, 16, 25 with one line of code. Welcome to Functional Programming. Today let's talk about map. You'll learn why it is used and when it's used and how to use it. Okay? So here's the problem statement. How to convert something like 1, 3, 4, 5, 6 to 1, 4, 9, 16, 25. Or in other words, how can you apply operation to each element and get an array to find a result in single line of code? Okay? Well, map doesn't work for you. Well, let's get into it. Let's find out how the map function works. So first of all, to appreciate the map function, all right, we probably go back to the non-functional approach to appreciate. So this is what you've probably done in the past. So we have numbers, an array, and number in numbers, square number dot append numbers times numbers. Okay, so right, the numbers 1, you do 1 times 1, 2 times 2, you append it, and at the end of the day, you have square numbers, a bunch of 1, 4, 9, 16, 25. All right, this is functional way. This non-functional way. Okay, so how many lines are there? 1, 2, 3, 4, 5. Okay, cool. That's cool, but that's interesting. That's interesting is not a good word. But we can do things like that in single line, like boom. Numbers, map, right there. You get 1, 4, 9, 16, 25 in a single line of code with how many letters are there? 1, 2, 3, 4, 5, 6, just a couple few letters. Okay. Well, today in this lesson, we're gonna learn how the map function looks like, and how to create our own custom map function. And then, yeah, let's code in a different league. Right? You never want to code like this. You'll always code like this from now on. Okay. Let's get into it. Well, first of all, as I already shown you last time, let's begin with non-generic map. All right, map. I don't like the word map, but I guess people call it map. If you want to apply some sort of operations to each element, you call it map. Yeah. Let's call it non-generic map. So only work with numbers. So let's call it function myMap. Okay. Enter numbers. Double. You're gonna work with double now. Operation. Again, functional programming is nothing more than entering a closure block to get the value you want. Okay, you're gonna enter double, and this time you're gonna return double. So if you enter 1, you can enter 2. If you enter 4, you can enter 16, something like that. Okay? And of course, we need this one. Call it result. This is what you're gonna return later down the road, like that. And for number in numbers, you do let transform. They call it transform value operation number. You enter the number. So right now, number can be 1, 2, 4, 5, 6, 7, 8, and 10. And you're gonna execute this closure block right here. And as you can tell, this closure block, you can define a closure block. That this closure block, what it does is take the double and then power or times by that, power by 2 or times 2 times of the value itself. You can create an operation later down the road. Okay, you can enter the operation closure later, and then if that has happened, we're gonna call the result append transform value right there. Okay, so cool. So we're gonna run this closure block. Okay, so that means we have to design a closure block, right? Well, we're gonna design one like a pro. So let's call it myMap. Let's execute the function myMap. You enter the number. Let's do 1, 2, 4, 5, 6, 7, and 10 like that. And in the operation section, you're gonna enter a closure block. And this closure block, you're gonna enter number first parameter, and then return double. You're gonna return double. Number times number. Okay. Now let's take a look at this. Let's do this print. Oh, it's not happening. Why is that so? Because you're not returning the value. So the function has returned something, right? Return double. And all the way bottom here, return double. And instead of using print result, let's call it result. And then print result. Okay, it should work now. Should return double array. Interesting. Oh, my bad. What was I thinking? Right there. So we have 1, 4, 9, 6, and 25. So what's happening is this closure block, we have to take a look at this closure block. This is the most important part. So you are running this closure block to each element within this for loop, right? You're executing this closure block, you're entering the value. So if you enter 1 in the closure block, it's gonna go through what? 1 times 1. If you enter 2, it's gonna go through 2 times 2, 4, 4 times 4, and as a result, it gets added to this array result, and then you return it, so you get 1, 4, 9, 6, and 25. That's it. That's what map function does. Okay? As long as you understand the functional programming and the fact that you use closure block to manipulate the data you're working with within the function, that's it. That's all there is. So now you can also do something like this. My map, enter the value that you want to transform, and you want to run a closure block which is applied to every single element through the for loop. You can do this. And of course you can return like that, but we don't have to. We don't have to. Come on, Xcode. We don't have to use it. Okay, again, if you're not familiar with closure syntax, please go to chapter 3 and master closure and come back. Okay? So now you know how to work with map, you know what goes behind the map function. But let's now make it more generic. That's what you want to make things generic, right? Well, let's make it. Let's call it slightly generic function. Slightly generic map. There's a more generic map, or let's begin with slightly generic map. Let's call it item this time, or you can call arrays. Items should be the better way of saying it. Operation. And you can enter T, and then it returns T. Okay, and then finally the entire function returns T, just like above here. Okay, just like the T refers to the result part. Okay, and then call it var result, which is empty right now. You can call it this way. Okay, and then you do for item in items result append. You're gonna run this operation block. You're gonna enter item right now. Okay, cool. Now finally we have to return result. Okay, that's it. That's you've learned how to design a generic map. You can work generic map. You can work with string, int, any type of data, as long as you define T. So T can be inferred or call that. You can explicitly say T, right? So now we can do something like this. Example 1, lowercase each element. So you have uppercase letters, and you can do slightly generic map. Actually, slightly generic map. Slightly generic map. You're gonna enter uppercase letter, and then you want to do some sort of operation to it. Well, instead of passing this closure block directly, let's design a closure. This time, let's use a global closure instead. Enter string. It's gonna return string. Return. Enter string dot lowercase, which is the default method that comes along with string. So now, operation, you're gonna enter lowercase, and this time you're simply entering the closure block without executing the closure block. So let's take a look at it. So now what you want to do is you want to print this right there. Boom. Bob, Bobby, Lee all become lowercase. How amazing is that? All right, one line of code, and of course you need to design this part, but we can simply enter closure block directly, so it becomes one line of code. So if you take a look at it now, this operation, lowercase, this function has been called on every single element. The Bob has been entered into the lowercase has been entered, and the lowercase Bobby has been going through this lowercase factory machine, and there has been lowercase. Lee also has been lowercase, like that, just like that. Okay, and of course you wanna think things like that. You wanna enter it directly. Call it letter. Let's call it its name. String in and letter name dot lowercase. Okay, we don't need return keyword because if you're not doing much besides returning only one thing, you don't need to have return keyword. We talked about it last time. Okay? That's it. I think we can also do this way. Slightly generic map, uppercase letters, and then we can do this. $sign and lowercase. I wonder if that works. We have to use a closure block right there. Like that. Let's see if that works. $0 refers to the name value. That's it. How amazing is this? Okay, compare this line of code compared to, I don't know, if you were to do it by yourself, alone, or if you were to do it back in the days, right? You know, it happens a lot when you're working with view controller. You want to code like this. You don't want to code like a bunch of random lines of code without having functions. And again, there's a built-in function called filter within array when you're working with an array. So, you know, it's literally become a single line of code when you're working together. So again, when you take the next course, you'll see how you can really truly minimize the number of lines you write when it comes to making UI, when it comes to networking. If you really learn how to use functional programming, and I'll plan to cover a lot in the next course when it comes to making UIs too. So if you want to learn how functional programming can be used in real life situations, I mean, talked about it, functional programming in an overview about it, but if you want to learn more in iOS development, how I use it, well, take the next course and you'll appreciate more. Okay? So this is a closure way, shorter form. This is a longer form. Okay? And you're passing closure directly. Oh, okay. I guess I was already prepared for this part. I guess I just did it without looking at the notes. Good for me. Okay, so, but here's the thing. This is not as extremely generic. This is generic enough, but this is not too generic. Okay? Okay, so you might wonder, how is that even possible? I thought this is generic enough. But here's the thing. You might enter, what if you enter items here? Let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are int. But when you run this map function, you potentially want to do something like this. So 1, 2, 3, 4, 5. So let's say we have 1, 2, 3, 4, 5, but you want to return things like 1, 2, 3, 4, 5. But what's happening? You are changing the type of what you entered, and you're changing the type after you've gone through the map function. That map function, what it does is that each operation converts 1 to different value, 2 to string value, 3 to 3 string value. How to do that? Well, we can make it even more generic. In this case, we're going to use call it extremely generic map. Okay, this is how the Swift engineers have designed the map function. They use this way. First of all, we're going to enter items, and the type of items can be just T. It can be it can be string, it can be int. Let's call it int. All right, we're going to use int later, and they do operation. We're going to enter T. We're going to enter the int value. Okay. However, it may return something else. So again, you may have a 1, but the map function, that operation function, may return string value, right? The string value becomes U. okay? U could be anything, but for now, the example I'm going to use, it becomes U. And then, at the end of the day, you're going to return U array. That's what you want to return. You want to return int to string value, so it has to be U, okay? So now let's take a look at var result. Var result has to be what? U. This is how you make an array, by the way. We talked about it last time. For item in items, and then we do result, append, and operation, execute the operation, item right there. Okay, so you enter the item is T, but the operation, what the operation does is the operation converts into U. It converts from int value to string value, okay? And later, and of course, you have to run the result return right there. Okay, remember the operation converts T to normal T. Okay, so I'm going to use an example like this, manipulate number to string value. So let's say we have a closure called convert number to our string. We're going to enter this closure block in the operation section. So if you take a look at it, this is int string. So int T is int, U is going to be string later. And then UR number, you get convert int value to string value. So let's take a look at it now. So you have a number, numbers, my numbers, okay? And then what you want to do is you want to do something like this. Generic map, enter my numbers, and you're going to enter the operation. You're going to enter this closure block, which is this one. This, again, functions are also known as global closures, right? They all share the similar things, numbers and return string, okay? So what's happening is this thing will return now. You're number 1, you're number 2, you're number 3, you're returning number 4, you're number 5. So what's happening is it takes that int value, and then this convert number operation applies to each element, and this thing becomes the string value. You are number whatever, and become your number whatever, your number whatever, and your number whatever, number whatever. So you get the point. So this is super generic, okay? Doesn't mean you have a value, doesn't mean it could be different value when you go through the operation function. That it allows you to do that, okay? Cool. So not only that, you can actually pass closure directly. Right now, you're passing closure indirectly by storing to not a value, you're passing closure block through creating a function, but you don't have to, you can just simply pass directly, generic map, enter my number. You can also use trailing closure because closure comes at the end. You could number, the number you're going to work with, number 1, number 2, and each number goes through that operation. You are number 1, you're number 2, and then here we go. I don't think we have to use this return, I believe. Yeah, we don't have to use it because there's nothing. And you can tell that whatever you work with is going to return string value. Okay, return is not needed if you're simply returning something. Simply returning one thing. Again, and also you can do one line of code. Just like that. Generic map, my numbers, and you are number 0, number 1, number 2, number 3. Okay, this is what's happening here. So hope you guys get what I mean by being super generic. If you learn generic by yourself, map, functional functions alone, these are tough. These are tough to understand. Hopefully I made my, because when I first learned these functions and learned what it means to use map and filter and reduce, it took me a while to understand, get my head around, to understand what the heck's going on. But hopefully I made the time, I've shortened your time, your learning time, because this was tough. And when I first learned functional programming, well, this could be a little tough for now still. But again, I'm available here. You're available here. You're learning it. You're gonna struggle. I struggle a lot when I learn Swift. You will struggle too if you want to get better. Some of you guys are better than I am, but if you want to get to better than I am right now, you got to struggle, because I did struggle a lot. I've read through the entire documentation many times to understand what this language offers. So, struggling is a virtue. You will appreciate more when you succeed. So, how to make things in the most pure way of doing it. So how to make a function like the filter like this. How to make a function like this. The built-in filter like this? Well, we're going to use a pure form, the sacred form, which is extension array. Okay, we're going to extend the array. And then here in this case, I'm just going to copy and paste. We do the same thing here. So we call it my map. Right now, U, there's no T. I'm going to explain to you why. U, we're going to use it. And operation, the element is going to be right there. But what does the element refers to? Element refers to the type of array. For example, right now, in this case, right now, the element, the type, element refers to type. The type is int. This is int. So you only need to define what U is. U is not known because you don't know what the operation will do. The operation might convert into string. The my operation might convert double. So you only need to know the T is already defined by the array, because you have to when you're working the array, right? The T is already defined because you know what T is. T is int in this case. Okay. And he's gonna return the final result and result. And for item itself, self refers to the array itself, and appended, and operation, what every operation can do. We can do this kind of operation. We can do multiple operations. So at the end of the day, you can use functions like this. Result, array, 1 to 10. You can use mymap, and refers to each element times 10. So it's going to be final result right there. It's going to be 1. Beautiful. Okay, so when it comes to functional programming, it's all about using functions, all about handing over passing closure blocks to work with. Okay, this lesson should be much easier than the last one, because now you understand the principle behind a map. Principle behind functional programming is nothing more than passing closure block to a function and executing the closure block for each element of an array to manipulate data. This lesson should be much easier than the last lesson, but still, I recommend you guys to keep practicing. If you want to know more practical application of functional programming, you can search Google and see what's out there. As long as you understand the fundamentals, the how part, application becomes much easier. You can apply anywhere else if you want to manipulate data, then use map and filter. Okay, so let's talk about in the next lesson. We'll learn just one more function. There are thousands of functions available, but these are one of the most common functions. And if you understand the fundamentals, later all you have to do is just read their source code and then see how they've done it. Okay, so get the fundamentals right, and everything works fine for you guys, and you're on the right path. See you guys in the next lesson. Bye-bye. Hopefully by now you're grasping the concept of functional programming. Again, you're nothing more than passing a closure block, and that closure block is executed within that entire function. That is functional programming. Once you learn functional programming, and you'll never code the same way you've done in the past, as I promised before. Let's continue with one more function called reduce, and see you in the next lesson.